we're going to talk about the mean and standard deviation of a binomial distribution, and then tomorrow we're going to talk about a geometric distribution. So we're still working with binomial, and how do we determine if something is a binomial distribution or a binomial random variable? Bins. We use bins to do that. So we'll still do that today, but we're going to move on and do a couple other things. We're going to find the mean and standard deviation. So what does the probability distribution of a binomial random variable look like? The table below shows the possible values and corresponding probabilities for x equals the number of children with type O blood, which we've already seen. This is a binomial random variable with n equal to 5. And p equal to 0.25. Okay. So then you guys making histograms, we're going to make another one. It shows the probability distribution. So we're going to go ahead and label. Make sure when you do this for your homework or your tests, we've just been putting X, but when you do the actual final exam, when you do the AP exam, you want to define what that is. So this is X, which is the number of children with type O blood. And then to the side, you did P of X which is just the probability. Along the side, they did it by fives or 0.05, 0.1, 0.2, 0.3, 0.4. I just didn't want to put all the 0.5. So you can do it at 0.15, 0.25, 0.35. I don't care. So then your probabilities, the first one is 23, which is right at the 25. The next one is 39, which is right at 40. Then 26, right above 25. 0.08, which is right below 10. 0.1. And just make sure you can distinguish between the other ones. Okay, sometimes that's just darkening that. So 0.00098. I'll give you a minute to finish that up. What is your shape?
Unimodal and right skewed.
Mm-hmm. And then just remember what skewed right means. In this case, the larger values are less likely to occur. If it were left skewed, the smaller values are less likely to occur. Your center, you would need to find where 50% is. Since this one is 23, approximately 24%, and this one is 39, when we add that up, the 50 falls within here. So your median is actually 1 because it falls wherever that 50% is. 50% of the data below and 50% above. I think we've already found our mean. You guys know how to find it in your calculator doing L1, L2. It's 1.5, so I don't need to go over that. Your spread is going to be your mean. If you're doing mean, should be your standard deviation. Again, you can use your calculator to find that. Or it's going to be the range. So the range is from 0 to 5. Whichever one you decide to choose is fine. Okay, but if you describe median, make sure that you use range or IQR. If you do mean, you're going to do standard deviation. So that's all for that page. So just reviewing histograms and describing them. Is everybody good with this page? All good? Almost. You sure? Everybody else okay? All right. So did you think about why the mean is 1.25? Because each child has a 25% chance of inheriting type O blood. We'd expect 1/4 of the 5 children to have this blood type. In other words, the mean of X is 5 times 0.25, which is equal to 1.25. So the 0.25 is that 1/4, and there are 5 children. This method can be used to find the mean of any binomial random variable with parameters n and p. So this is how you're going to find the mean and standard deviation. These formulas are on your formula sheet. So if you want to use it, remember your formula sheets are on Canvas. So anytime you take your test, if you need that, go ahead and use it. So here's how you find it. Your mean of X, real simple formula, equals n times p. There are fairly simple formulas for the variance. And standard deviation, but they aren't as easy to explain, but we will. So those formulas, the variance, you would do 5 times 0.25 times 0.75. Where does 0.75 come? Where's that from? Yeah, it's like your failure. So your success would be your 25% and your fail would be your 75, which gives you 0.9375, which means that your standard deviation is the square root of that, which is 0.968. So for our family with 5 children, the mean is found by doing n times p, and the standard deviation, here's what it is n, that's your 5, p is your probability of success, and then your 1 minus your probability, so your failure probability. So those are the 2 formulas that you need to get out of today. Okay. All right, so all of this stuff that's going through is going to describe why we do this mean and standard deviation form, and then you're going to practice doing it as well. So just to reiterate, the mean and standard deviation of a binomial random variable, if a count X of successes has the binomial distribution with the number of trials n and the probability of success p, the mean and standard deviation are, just to write the formulas again, mean of X is n times p, standard deviation is the square root of n p 1 minus p. Remember that these formulas work only for binomial distributions, only for binomial. They can't be used for other ones. All right. So where do the binomial mean and variance formulas come from? So they're going to derive these formulas. So this might be the worst part of the notes, like where you have to actually pay attention to it. All right. So if they give you a value of 0 to 1, 0 is going to be your 0 is going to be your fail, and 1 is going to be your success. If you look, P is your probability of success. 1 minus P is your probability of a fail. All right. So you can think of B as representing the results of a single trial of some chance process. If a success occurs, which is probability P, then we're going to represent that with B equals 1. If a failure occurs, then B is going to equal 0. So this is a failure, success. This is the success probability. This is the fail probability. All right, so the mean is really easy to look at, okay? The mean of B. Remember how we find the mean? We take these two and multiply them together. So the observation times the probability. And then we add it to the next one, observation times the probability. Anything times 0 is. So all of this right here gives you 0. What's 1 times P? So that equals P. Again, our N is 1 because we only had one chance of getting anything. So that's why it's not showing NP right now. It's because we had a 1 for our N. All right, the variance of B. This is the one that's hard to follow. Okay, so pay attention. It's just algebra. Remember to find the variance. This is what we did. Observation minus the mean squared times the probability. So that was the first one. Observation minus the mean. They're all P's. They're all P's. Observation minus, what do we find to be the mean? P. That's okay. That's why I say it's hard to follow. That's okay. I just want you to know where it comes from, and then the algebra part, you kind of get lost in. It's really crazy. Plus, we got to do the other one. The observation was 1 minus the mean that we found was P squared times the probability, which was P. All right, so we're going to clean it up. What is 0 minus P squared is? P squared. Okay. Over here, I'm going to do a bracket. 1 minus P twice times P. I'll come back to this. We're going to clean it up in the front first, and then we'll work on that. All right, distribute your P squared. We get P squared minus P cubed. Everybody okay with that part? That's the easy part. Trust me, that's the easy part. All right, follow the rest of it. Distribute. 1 times 1 is 1. 1 times negative P is negative P. Negative P times 1 is negative P. Negative P times negative P is P squared. And then don't forget we have to multiply it by P. I'm going to clean it up, and then I'll distribute that P. So this doesn't change. 1 minus 2P plus P squared times P. Is everybody okay with that part? Negative P plus negative P is negative 2P. You're going to distribute again. So I'm going to distribute this P in. So we have P squared minus P cubed in the beginning that we've had for a while. 1 times P is P. P times negative 2P is negative 2P squared. P times P squared is P cubed. Clean it up. Your P cubes cancel out. We have 1 minus 2, which is negative P squared. And then we have a plus P. We're going to take out a P. Leaves us with negative P plus 1. And then I can rewrite this as 1 minus P. So that's your formula from up there. So this is the variance formula. Let me go back real fast. Your variance was right here in P minus 1. It's the same thing that was right here. But remember, we don't have an n on this one because our n was 1. Got it? So there's your formula. So I just wanted you to see all the work. They just throw it out really weird in the book, so don't look at it. Are you going to have to derive formulas? Absolutely not. They just want you to know where it comes from, okay? So that's pretty much it on that. So then now consider the random variable x, which will equal b1 plus b2 plus all the b's until you get to the very last one, and we'll call that bn. We can think of x as counting the number of successes in n dependent trials of this chance process, with each trial having success probability p. In other words, x is a binomial random variable with parameters n and p. By the rules from section 6.2, the mean of x is, so to find the mean of x is an addition. We would do the mean of the first one plus the mean of the second one until we got to the mean of the last one. All the probabilities are the same. That's why it's binomial. That's why we do bins until you get to the last one. And we can rewrite that as how many ever p's that we have times that actual probability. The variances work the same way. Variance squared of b1 plus the variance squared of b2 until you got to the variance squared of the last b. So the variance is the success times the failure plus the success times the failure until you get to the very end. So that means we would have how many ever p's times p times 1 minus p. And then to get the standard deviation, it's the square root of the variance. The variance formula was n p 1 minus p. Again, all that's doing is deriving that formula and getting you to understand where the n comes from. So if you have multiple probabilities and you're adding them together. All right, so the big thing is, remember, what's the formula for mean? NP. What's the formula for standard deviation? It's right there. Perfect. These are the formulas you need to know. All that other part was just deriving those formulas and where they came from. So if you didn't get any of that, it's okay. It's not important. All right. So here's an example of binomial distribution in action. Mr. Billiard's AP stats class did the activity on page 346. There were 21 students in the class. If we assume that the students in his class could not tell tap water from bottled water, so that what they were doing was they had 2 different waters and they were trying to taste to see which one was tap or which one was bottled, and they guessed which one. Then each one was basically guessing with a 1/3 chance of being correct. Let X equal the number of students who correctly identified the cup containing the different type of water. So explain why X is a binomial random variable. How do we explain how it's a binomial random variable?
Bins.
So remember that. All right. So I'm going to start with B. What's your success? What are we wanting?
Correctly identifying the type of water.
So a correct ID. So your fail would be? Incorrect, ID. Good, so it passes the first one. Is it independent? Mm-hmm. And I'm just gonna write this out for you guys, just for reference. One student's result tells nothing about the next. Me too. What's your number of trials? It is 21. There are 21 students who are guessing. Yeah. And then your success probability is? One-third. So is it a binomial random variable? Yes. All right, find the mean and the standard deviation of X and interpret each value in context. Don't forget to interpret. So what's the formula for mean? What was our N? Our P? 21 divided by 3 is 7. Here's my interpretation. If the activity were repeated many times, why do I have to say that? Because it has a probability attached to it, and probability is long run. So if the activity were repeated many times with groups of 21 students, guessing, the average number of correct guesses would be 7. How do we find standard deviation? Mm-hmm. Times 1 minus P. Okay. Square root. Our N was 21. Our P was 1/3. So if our success is 1/3, our fail is 2/3. Remember, it has to add to 1. This gives us a standard deviation of 2.16. This means that the number of correct identifications would typically vary from the mean by about 2.16 guesses. Part C says, of the 21 students in the class, 13 made correct identifications. Are you convinced that Mr. Bullard's class, two different names there, students could tell bottled water from tap water? Justify your answer. So how do we figure that out? We're going to look at the probability of what? So what, how many were successful? What did it say? 13. Now listen to this carefully. There were 21 students. There were 13 correct identifications. What's going to happen is you need to make sure, you can do it this way, it'll be fine. But what they're gonna have you do looks like this. So there could be 14, 15, 16, 17, 18, 19, 20, 21. We're doing those and above, okay? We don't want anything less than that. So what that means is we want the probability that X is less than or equal to 12.
Why are you doing greater than if the problem just said that they made like 13 right at 13?
Because even if they made 14 correct identifications, that would still be 13 correct. If they made 15, that would still be 13 correct. Does that make sense?
Yeah.
Okay. So you have to include all those because those would still be 13 correct. All right. So then you can do it by hand. We're going to do some later by hand, like review them, but we're not going to do this one by hand. We need to do the binomial because we know it passed bins. Are we doing CDF or PDF? CDF. What is our N? What's our probability? 1/3. And then what is our X value? You use 12. Remember, we use 12 because we want 12 and less because they were not correct, okay? So then we get 0.0068. Are you convinced that they could tell bottled from tap? And that's it. Seriously, it's already been 40 minutes. Doesn't really, oh, it's been 30, but still. All right, flip your paper. All right, so the figure below, and I didn't show the figure, but I'm going to kind of sketch it out for you. It's crazy. Shows the probability distribution for the number of correct guesses in Mr. Bullard's class if no one can tell bottled water from tap water. As you can see from the graph, the chance of 13 or more guessing correctly is quite small, and I'm going to show you that graph. It's on page 400. But it looks like this. It starts small, and then it gets bigger, and they've done a whole bunch. So this is just a sketch. But then it gets really teeny tiny at the end. Okay. And you can look at it on page 400. You don't have to. I'm just trying to give you an idea. So anything up here is going to be really, really small. All right. So refer to the previous CYU, check your knowledge or check your understanding, page 397 about Ms. Desai's special multiple choice quiz on binomial distributions. We defined X as the number of Patty's correct guesses. So just to let you know, we were guessing multiple choice A through E on a 10-item test. So she didn't give them any questions. They just had to guess. So our amount of items or N was 10. And our probability of being correct, you get 1 out of 5 or a 0.20 chance. But that was from Friday or from Thursday. All right, so just to bring that back, all you need is N and P. Find the mean and interpret the value in context, find the standard deviation, and then what's the probability, and we'll talk about the probability in a minute. Okay, so number 1, find the mean. How do you find the mean of X? NP. I did them backwards, I apologize. N is 10, P is 0.2, which gives you a mean of 2. Interpret this for me. What do we got to start with? Say it again. What'd you say? You can, after many. Just make sure that you say multiple attempts. So this one is, this is my interpretation. If many students took the quiz, we would expect to see about 2 questions correct on average. You can say an average of 2 questions is what we would expect to see after many people took the quiz or after many quizzes. Just as long as you put many in there. Yes, you do have to put many because you have the probability. Standard deviation of X. How do we find that? What's your formula? So our N was 10. Our success probability was 0.20. So what's our fail probability? 0.8. That gives us 1.265. If many students took the quiz, we would expect the number of correct answers to differ by 1.265 from the mean. Any way that you can say that. All right. So what's the probability that the number of Patty's correct guesses is more than 2 standard deviations above the mean? So look at this. This is the probability that X is more than the mean plus 2 standard deviations. Okay, and I wrote that down so that you can see where these numbers come from. All right, so that's the probability that X is greater than, what was our mean? What did we find to be our mean? 2 plus 2 times, what was our standard deviation? Which is actually the probability that X is greater than 4.53. So I wanted you to know where the 4.53 came from. Can we do greater than probability? No, we have to do 1 less than. Okay, so 1 minus. So we're going to do 1 minus the probability that X is less than or equal to. And when we look at this, you can't get a 4.53 questions right. Y'all understand what I'm saying? So if we want it greater than 4, that means technically we want it greater than 5. Is everybody good with that? Or equal to? So this is going to have to be 4. Okay. So anything less than or equal to 4, we want to take out. Binomial CDF or PDF? CDF. PDF is equal to, think about it as P is perfect, so equal to is perfect or exact. What's your N? How many questions do we have? 10. What was your probability? It's okay. Success probability was? So the top success probability, 0.2. And then your X value, what's in our probability? I mean, I was right, in our probability. Put that 4 in. When we do this, we get 1 minus 0.9672 or 0.0328. Okay. You can put this line right here all in your calculator. It'll do 1 minus in the binomial command. That's fine. I'm just showing you what that value was. Okay. What do I got? 2 minutes. Let's go ahead and go out and come back in. We're almost there. Not too bad. All right, so I'm gonna stop sharing, stop recording.